Hi everyone, just wanted to take a moment to talk a little bit about rational exponents and how you can solve different equations using the different properties of exponents. Um, so first thing we want to talk about in regards to rational exponents really comes down to what exactly is a rational exponent. So a rational exponent is just if you had something like a raised to the, m over n power, where m and n are just some numbers. Um, so that's really what we're going to be dealing with now. These are rational exponents. In the past, what we had dealt with was like you just had a to the m. Okay, now we're giving that the potential for a denominator. So what we have to do is kind of explain what does that mean? Well, whenever you have something like this, x to the 3 halves, essentially what you're going to do is you can treat this in the following manner, right? You can treat this as x to the third to the 1/2 power. Well, I know what x to the third is, but the 1/2 is a little bit confusing. We're essentially saying we want something that if we squared it would become x to the third. So I need the square root of x to the third. Okay? So the square root of x to the third would end up being x to the 3 halves. Yeah. Okay. Now there are ways you could simplify this a little bit further, but that's not what we're looking at right now. What we are looking to do is we are going to rewrite the rational exponents into rational exponents, right? So this is 18 to the third root. So that would mean we would have 18 to the 1/3. Whatever this number right here becomes the denominator of your rational exponent, okay? So this is the numerator of your rational exponent. This is the denominator of your rational exponent. So even though we have a b and an f, right? It's just b to the, that's an f. It's the worst f you've ever seen, but it's an f. F over 3, okay? So that's all we're looking for here. Going through from radicals into rational exponents is really helpful. Whatever this number is, it could be to the 7th, the 7th root of x to the 12th, whatever. You would have x to the 12 over 7, okay? Whatever this number is becomes the denominator of your rational exponent. So now how can we do things with this? Well, we can solve problems with it, right? We can solve equations using rational exponents. We could do it using regular exponents as well, but now in particular, we're going to be looking at it involving rational exponents. So using what we know about the properties of exponents, we're going to solve these equations. So in the past, right, when you had the product of powers, right, when you had, a number times another number and they had the same base, which in this case they do, 6, you could add the exponents. So same thing. I don't know what that is, mind you, but you can do it. And it equals 6 to the 6th. So, right, if they're both 6 raised to a power, what does that mean about my expressions up here? I know that this must be this. Okay? I don't know what they are yet. I'm just saying they have to be the same. Somehow this has to equal 6. So I can figure this out. Now, I'm going to multiply everything by 20 and just clear out the denominators. When I multiply everything by 20 here, that would end up being 5x plus 4x. And then 6 times 20 is 120. Okay? I just multiplied everything by 20. And the only reason I bothered with that because I don't like fractions. I don't want to deal with them. They're great for working and manipulating things, but they're even better to just get rid of. Okay, so I have 9x equals 120. So x equals 120 over 9. Now I can simplify that, right? We know this is 40 times 3 over 3 times 3, so that would end up being x equals 40 thirds. And I know you don't like that as an answer, but that is actually our answer. So if I put in 40 thirds here, these would simplify to 6. Okay. Now, how could you actually go about checking that? Well, you could plug it in. So 40 thirds over 4 plus 40 thirds over 5. Well, this would be 40 twelfths, 40 15ths. And you have to figure out how to deal with that. I would say 60 would probably be the best base here. So that would be times 5, 200 over 60, times 4. So that would be 360 over 60, which is 6. Okay, so that is right. I know it's not exactly pleasant to look at or pleasant necessarily even to do, but it does simplify down to 6. Okay, so your answer is just 40 over 3. Now, let's use some of our other properties. All of these, mind you, are going to have the same sort of process. The goal is to get the same base, right? I need the same number. Here, I had a 6. Here, I had a 6. Simple enough. I already had it. Here, I have a 16. Here, I have a 64. Not quite what we're looking for. We want the same number. However, what do we know about different powers? Well, 16 is equal to 4 squared. Okay. 64, well, it's equal to 8 squared. It is 8 squared, but it's also what? If you look at 64 and you were to divide it by 4, you would get 16, right? So this would be the same as 4 to the third. And you can check that if you want to use a graphing calculator. 4 to the third, 64. Okay. Now, I can use that to help me solve this. So I'm going to rewrite this. 4 squared to the 3x minus 6 equals 4 cubed to the x plus 2. Now, what do I know from my different properties of exponents? Well, we have a power to a power, right? So I can multiply these. So this would be the same as 4 to the 2 times 3x minus 2 times 12, which is 2 times 6, which is 12, right? And that's equal to 3 times x plus 6, all right? So now I can go through the actual process of solving this. I'm going to erase this because I need more room. Okay, so if I'm going to go through the process of solving this, let me just set them equal. That'd be 6x minus 12 equals 3x plus 6. Okay, we would then get 3x equals 18. X will equal, once again, 6. Interesting enough. If we were to plug this in, 6 times 6 is 36, minus 12 is 24. 6 times 3 is 18, plus 6 is 24. Okay, that'd be the same. All right. So with these ones where you don't have the same base, you need to get the same base. So I really highly recommend looking at that chart of powers. I don't expect you to know all of them off the top of your head. You know, there'll be some common ones that you could know. In fact, like 4 to the third should be pretty reasonable. Obviously, like I get it. Sometimes you have a moment where you're like, I don't remember what it is. I even in my head, as you could tell, did just double check, make sure I was right. It happens, but you know, the more you practice with them, the more you'll get familiar with. All right. So now let's look at something like this. Okay. So when you get the next one down, we're going to essentially use the same property. And I'm just double checking, make sure my number's right. Okay. Yeah. Okay. So when we have something like this, the first thing we want to think of is we have a fraction. We don't like those. So we're going to get a negative exponent, okay, right? Because we know when we have a negative exponent, we can just flip it over. But let's also think to ourselves, what can we do with 3,125 and 125? Well, the 125 should key you in somewhere. Maybe not this one, but the 125 should. The 125 should key you into 5, all right? And if you check your chart and say, well, 5 to the what power is 3,125, it turns out it's 5 to the 5th. All right. So let me do this one. We have 1 over 5 to the 5th negative x over 4 is equal 1 over 5 to the 3rd negative x over 3 plus 1. Okay. So now we can bring this up, and it'd be 5 to the negative 5. Let me do that. We have 5 to the negative 5 negative x over 4. 5 to the negative 3, negative x over 3 plus 1. All right, so again, we'll just, it would be 5x over 4. And we distribute, right? Multiply. 3x over 3, which is just x, plus minus 3. Okay. And what did I just do here? These would be 5 to them, but I'm just loading that stuff. So now, well, I'll subtract this. That would end up being x over 4 is equal to negative 3. X is equal to negative 12. Okay. X is equal to negative 12. And again, you could plug these in to double check. All right, let's look at the next one. We have to solve this. Again, we need the same base. We have a 2 and we have a 2, so somehow we have to get 2. Now, if you want to check this, you can just keep multiplying 2. The powers of 2 should be pretty reasonable for you to remember. So, right, 2 squared is 4, 2 to the 3rd is 8, 2 to the 4th is 16, 2 to the 5th is 32, so 2 to the 6th is 64. If you really played the game 2048 a while ago, that was huge. You know, you might have a leg up on some of the powers of 2. All right, anyway, so this is 2 to the 6th. So 2 is equal to 2 to the 6th to the 1/3 x, 2 times x to the x over 3. Okay, so let's go through that process. So 2 then equal to, again, we multiply power to a power. 6 times 1/3 is 2. Now, we're back at the original scenario we started with. These are just multiplied, same base, I can add them. Now, somehow this has to all equal 1, right? Because this is the first power. So that would mean that 1 is equal to 2 plus x over 3. Multiply everything by 3. 3 equals 6 plus x. X will equal negative 3. All right? Now, last one that we have to deal with, and this is when we're dealing with quotients. Again, for us to do any sort of kind of sizable process with this, let's worry about finding the same. Base. Okay. So this is teeing you into 4. We've already said that, you know, this is 4 to the 3rd. We already know that this is 4 squared. So we know that 4 to the negative 7 thirds is equal to 4 to the 3rd x to the 3rd over 4 squared 4 to the 3rd. Okay, this is a power to a power, so we can multiply. 3 times x over 3 is just x. 4 to the 8 thirds. Now, we have a power of the same base, so we can subtract. There's a couple different ways you could do this, by the way. But this is, I don't know, I feel like this makes the most sense. Now, same thing. Set them equal to each other. I've run out of room again. Negative 7 thirds equals 8. Nope. Equals x minus 8 thirds. I'm going to multiply everything by 3. Just get it out of the way. Negative 7 equals 3x minus 8. 1 equals 3x. X equals 1 third. Okay. And there you have it. So these are kind of the different properties. Ultimately, all you're doing is you're using the properties of exponents to solve equations. If you get the same base, you can set the exponents equal to each other because you know they must be the same on both sides of the equation at the end of the day. These are tough, okay? So we are going to take some time to practice with them, but they are difficult. If you're not 100% on them, that's okay. It's all right. This is not in any way, shape, or form the most important thing we're going to be doing this year. If you forget how to do this after we do this, there will be further opportunities to practice. Don't get help. Don't get too upset if you're not doing phenomenally on this section. All right. After this, we're going to move into exponential functions, and we're not necessarily going to be doing a lot with this. All right. So do your best. Try your hardest. Let me know if you have any questions. Have a great day.